Okay, good morning, everyone. Please don't forget today, your due date for assignment one. You have all day to complete it, and please submit before midnight. This week, you are going to have another quiz and assignment two. I am going to describe assignment two in our next lecture, and the same day, we're going to open the quiz. So quiz and assignment, and you're going to have 1 week to complete them. Now, continue with the lecture previously. You remember our classes, and hopefully all the decisions that we take about the content for each of the classes is clear. Remember, the important thing is not for you to be experts programming the Pac-Man, but the process that we are following, the decisions that we take. Now, we have these classes in the previous lecture, more classes. And the expectation is these classes solve the problem. Now, hopefully you remember we talk about diamonds, black. And we have this justification about those 3 elements be mandatory, black diamond. We have this idea about adding a parent for those guys, which imply a method that is going to be present in all of them. And we use another Java class for a panel, and then with that we can put the panel inside of this game that is a frame. So a panel inside of a frame, the mesh inside of the game, and we decide to use things here and make some implementations there. And those lines and those connections define what we are doing. Now, the mesh, we define that is not going to be drawable. It's just an aggregation here, it's a diamond. Because remember in this one, we have this paint component. That is the method that we use to draw things in the panel. And for these guys, we define this draw method. What is going to happen is, well, since this one have this one, this method is going to be able to call this method. So we're going to make the connection. Now, we start describing the source code. Is if I give you this diagram, this idea, these connections, well, each of the connections represents something in the source code that you need to add. And the idea is that should be, abstraction, encapsulation. Ideas that I am sure you learn in your programming class, but we need to review deeper. Simplicity. We reviewed this one, the interface, the green box. Pretty simple. The only goal is create a parent for a group of classes. It's a good idea to have a parent. We're going to see why. Now, we review the power dot, draw. This is the one that is going to do the drawing. Check something. The only thing that the class do is very simple things. I am going to do the draw. The position is according with some variables that I have. I don't care about the value. I use draw my work with my variables. There is a constructor. In the constructor, you can do initialization of variables. That is what constructors do. It's not just because this is this particular class. Any class have a constructor. Any constructor put initial values to the variables. You need to change the values of the variables. You create getters and setters. It's just what is expected to be in a class. Now, similar, if you look the other variables. The draw is a little bit more complex, quotation marks, and you have all these methods. We give them names that represent something, up, down, and so on. These are setters. Set position X, set position Y. The only reason because instead of two method set, we create this is semantic. It have more meaning up than set position Y equal position Y minus 20. Something that you want to do in programming is make sure that your program is easy to read for another human being. That could be your classmate or your teammate. So if adding this method with those names help me to do that, you can change the name setters, whatever, for up, down, left, and right. And that makes the Pacman. We reviewed this one. Similar idea or exactly the same process. Variables and the draw. The draw, only one line is important. All the other things, how this thing should move. How the thing should move, you can define another method that calculates the new position. At the end, the moving is just this method that gives you a new X and Y coordinates. And you can use whatever algorithm you want. We reviewed that before. Now, in the previous lecture, we didn't finish with all the classes. Those three, the classes plus the interface, very simple. But they cannot work alone. They are just an element in the diagram. And we need to connect those elements with the other part. The most important, the one that have the main, the one that is going to be the one running. Well, all those three elements are inside of the maze. If you notice, I am reading the diagram bottom up from the easy things to the main. Now, for the maze, the maze is not drawable. We represent it different. We make a panel because we're going to add this to a frame. We explain that with the diagram. And the important thing is this method. That is the paint, right? That is the one that is going to do the drawing. Now, for that method, there are obviously instructions that correspond to programming graphical user interfaces with Java. For instance, always a paint component is going to call the paint component of the parent. You use super, in this case, in order to paint the panel, and then inside you paint whatever you are doing. So that line is going to be there, the 11. Starting down, I draw some lines just for you to give you an idea about a maze. Instead of the lines, line 12 and 13, you can draw the maze there. Again, the only thing that I need is a method, and this method needs to draw the walls somehow and put on the screen whatever you want. I don't care about the Pacman, just drawing something. Lines, horizontal, lines, vertical. If you notice, the only thing that I need is to use this object, G, and G have draw lines, draw ovals, draw rectangles, and so on. Anyway, agreed. That part is the important one. In that position, I am asking the paint in maze to call the draw methods in all the elements that I have from this class. Remember, we have this aggregation of things between the maze and the drawables. For instance, if I want 3, I create an array of 3. Here, I have my array, and well, they are going to have any element, any child of draw. The only thing that I can do here is a loop, and for each element in the array, call the method draw. The important thing, this is the method that have access to the object G. The object G is like the screen, the canvas in which you are drawing. If I want the others, the Pac-Man, the Ghost, the Power Dot, to draw themselves, what I need to do is this G go as a parameter. Sending the G to others, other classes or other methods, allow them to draw something on the screen. I am sharing with them the screen. Think about it. You are drawing something, a piece of paper, and when you share that piece of paper with another human being, a classmate, well, that person can draw something in your piece of paper. In this case, the screen. That is the paint. Every single time that I draw the maze is going to be drawn, and also the elements that are inside. Nothing else to do. Now, the constructor. In the constructor, the only thing that I am doing is, well, I need to put elements inside of the array. Put elements inside of the array. As always, number 1, you can do the new for the new element, like I did for the power dot. Number 2, you can receive the elements as a parameters. They can be in a different class, like in game, and game can send those elements to you as a parameters. You didn't create the elements, you are not the owners of the elements, but you receive those elements as a parameters. They are not your property, but you can use them. In the same way that this draw is going to use G, even though G is not part of those classes or inside of those objects. So I give you here both examples, as we decided in the previous lecture, like, well, I am going to make Pac-Man and Ghost be inside of game. Game is going to share that with maze parameters. I have these 2 parameters, and the power dots, I didn't put the power dots inside of game. So I make the new here. Both options work. You can do the same with Ghost and Pac-Man as the power dot, or the same that we did with Pac-Man and the Ghost, can we do it with power dot, move this to game. At the end, is your decision. We need to talk about which decisions are better. We need to talk about the rules. The only rule that I mentioned in the previous lecture, and I insist now, is it's a good idea to have all the news in one class. In this case, it could be a good idea to have all the news in game. Therefore, my solution for this particular version of the problem could be to move power dot to game, send power dot as a parameter here, and therefore here I do not have another new, use the parameter power dot there, and with that I initialize the array. Now, something that I want to be clear here. If you notice, for the first time I am using an array, and arrays have a new for the array, but also you could have news, unique news for the elements of the array. We need to remember that in Java, in general, when you are doing arrays in the heap, not in the stack, something that happens is you need, your array is a pointer or a reference, and therefore you need a new to create array, but that array for primitive data is the one that is going to have the values. But if you have an array like this for objects, this array is an array of references, pointers to the real objects. So in order to put something here, you need a new, and that new is going to create the element itself. And the same for the others. So talking about arrays with objects like these, items, I need the new for the array of references, and I need the new for the elements. I need you to remember this connection. This diamond, white or black, is about whether or not the values are mandatory. So the fact that I have here an array and the fact that I have here a new, that doesn't mean that this diamond should be black, because this new is giving me these 3 elements or whatever number of elements I need, but the value at the beginning in Java is null. And if the values are null or can be null, you are talking about aggregation. In fact, I am using parameters, aggregation. It is not composition because it's not the class, the one that is doing the new for the elements. The new for the array, again, is irrelevant. The new for the array is just checking that I want 3. Okay, you want 3 of these 3. In order to give you those 3, I do the new, but that's it. It's 3 elements, but so far in this line, they are null, they are empty. And if you allow that, your diamond is not black. Now, moving forward, what do I need to do in order to have the diamond in black? Well, in the constructor, initialize all of them. If in the constructor, I do the new for the power dot, and I do the new for the Pac-Man, and I do the new for the ghost, then it's composition, because they are mandatory, because if I run the constructor, all of them are going to be created. However, here, number 1, I know that the Pac-Man and the ghost, the news are in game. So the black diamond go with game. Second, even without looking at game, if I check this class, every single time that you receive something as a parameter, the only thing that you know is you're going to receive this parameter. What if the parameter is null? You're expecting an object. Someone can send null as a parameter, right? And because the possibility of sending a null as a parameter is valid, it's going to compile, it's going to run. Your diamond is not black because there is nothing in the program making mandatory that this item 0 and item 1 have a value different from null, obviously. So this code is that relationship. There is no 100% guarantee that the 3 elements are different from null in this case. Maze and game, well, they are going to be connected, or in this case, maze with drawable, they are being connected, but in this case, diamond is white, no black, because of this. And this new, the only thing that it's doing is the 3 elements, nothing related with something that impacts the diamond. It doesn't matter if you are copying the values from one object to another. The question is, you can receive nulls by any condition. The final value in the local object is going to be null, can be null, yes or no? That is the question. So in a copy constructor, can you copy a null object, and therefore the one that is local be null, well, have null values? Yes, no, maybe. Remember, the null or the emptiness is not about the object itself. I mean, you are using an object and you're going to copy here the same values that this object has, right? So this is obviously not null. The question is, this one, inside, the values that you are going to copy, they are empty, they can be empty, they have been null, like this one have another object inside, that other object could have a value null, because this, what is inside is what you are going to copy. Yeah, null pointer exception if this object is null. But remember, what you are trying to do is to copy the attribute of this object inside of this object. That could be the copy constructor. So what you need to check is whether or not the elements inside of this one can be null or not, because that implies that this one is going to have or not null values after the copy. Good. Okay, again, decisions. So far, what I want you to be aware is the source code and the lines match, and there is only one representation of the diagram for a particular representation of code. What I need to review with you next week is which is the best connection, because again, it is better in this particular case, white or black. What is the consequence of one or the other? There are patterns of the solutions for those questions, because we are not the first ones trying to decide if we want a black or a white diamond. These kind of problems, not only with the Pac-Man video game, but these are the same problems that you face every single day when you are doing software design. There are solutions that we need to learn instead of reinventing the wheel every single time that we try to connect to classes. But next week. Well, we can, but again, when we saw the full picture. Here, the point is, these two, I know in the other class that they are not going to be null in the other class. But for this class, I do not know. This class, remember this idea of encapsulation is I cannot take decisions inside of one side thinking about knowing others, because those others can change. And that means that I am not aware of those changes. So in this scenario, two reasons. Number one, every single time that you receive parameters, the standard solution is if they are going to be parameters, I am going to use the white diamond just because that is the safe way to play. Parameters, white diamond. Because as parameters, if I am receiving parameters, I am not going to take responsibility of saying for sure inside of me they have a value. And number two, here particularly, because I am playing with this combination of parameters and no parameters, just to give you an example, I am going to do a change in the next slide. So I use the white to play safe. But in general, parameters, white. That could be another rule that we need to review. Did one have an aggregation of drawables? We're working this one. So we're working this maze aggregation drawables. And in particular, well, I am using these three elements. I give you an asterisk here because I am going to add more, but that is the part that we're working. This is my aggregation. Anyway, now, This is maze, my last connection, the core of this game. For game, do you remember all the boxes that we connect up? It's like, well, extend the frame, action listener, key listener. I am going to need the action listener because, as I mentioned before, it's connected with the use of the timer. So I need to add the implements. And I can implement several interfaces. So I am going to need the key listener. I am going to need this one. It's a frame, my class. Now, the composition, okay, composition. I make these three things here, good. But in order to have the composition, I need they to have a new value, my constructor. In the constructor, well, mandatory, and I am going to create the maze, as I mentioned before, pass as a parameters. If you want to create here the power dot, you can send also the power dot down and 3 parameters. That's it. I am the owner as a game of those elements, and then I can share those elements to other classes, sending those elements as parameters. The only one that is sure that those elements exist is this class. Therefore, for this class is composition. I have them, I create them. For the others, they are receiving parameters. And because you are receiving parameters, you do not create the elements. It's like they are being aggregated to you just because you have no 100% security that they are not going to be null because they are parameters. The constructor shows that maze. Yeah, that is the point. You can pass null. Game, new, black with maze, black with ghost, black with the Pac-Man. That is these 3 news and parameters. Good. Okay, now adding the maze to the frame. This is the instruction. Use add. And I want in the content pane, I want the panel to use the full space and add the key listener, the one that is going to be listening for my keyboard. I do not need to add the action perform. In fact, I do not have any element with the action perform. It's going to be the timer. So I am going to need to do something with the timer, but I can do that later. Why later? Because before start the timer, I need to be sure that the screen is ready. And that is going to happen after this constructor finish. So nothing related with the timer in the constructor. The only thing with the constructor is the news for my objects and go ahead adding things to the screen, in particular adding the maze. And remember, when I add the maze is going to call this paint component, and this paint component is going to paint the first version of these guys in any position that is the initial value, 0, 0, 1 class have 400, 400, whatever, version number 1. Now, something that I have, I put in a method. Remember, your methods are like your paragraphs. So it's a good idea to put paragraph methods that do particular things. So something that I need to do is the timer. The timer, I can have this method because I need to do 2 things with the timer. Obviously, I need to create the object timer. is an object, it's from the classes. And I need to start the timer. Two things. I can copy paste those two lines in the place in which I am going to call start timer, or I can have this start timer method. Recommendation. If I have the method and later I want to do other things here, like moving from timer to threads or whatever, I have this paragraph, and if I need to delete, I can delete the paragraph, or if I need to modify, I can go and modify my paragraph instead of going and search in my program for the lines that are related with this thing. Yeah, 2 lines is too small. It's a very small paragraph, but recommendation, put things together, create groups, starting with the method. Anyway, right now this method, the only thing that it have is create a timer, run the timer. I need to call this method because right now it's not being executed, not in these lines. Now, this one for game is going to make the connection between game and timer. And remember, no composition, no aggregation. You're creating an object, yes, but it's a local variable, not a global variable. When you have local variables, even objects is not aggregation, no composition, no diamonds, obviously not inheritance. The only thing that you have is user connection, and you have this one using the other. Not having, not is a, use I am using a timer because, well, I am going to call a method. And obviously, in order to call a method, I need an instance. That's it. We have this arrow in the diagram that I showed you before because I am going to use that element. Moving forward, here, this is the action performed that is going to be called by the timer. Notice that one of the parameters for the timer was this, and you remember when you do the add action listener, you pass as a parameter the object that is going to have the action perform method. In this case, the same class. So the action perform is in the same class and it's going to be called when the timer activate that. So this is the method that the timer is going to call. And the only thing that I am going to do every time that the timer activates is call the repaint method in maze. Maze have a repaint method because I am inheriting from jpanel. So jpanel give me the repaint, and the only thing that the repaint do is to call the paint component, and in the paint component is the method in which I am drawing these lines, the grid, and calling the draw to the Pac-Man, the ghost, and the power dot. So this is the point in which all these calls start. And this is called every 10 times per second. 10 times per second, I am drawing my screen. I am not using double buffer or any fancy thing with games. That is not my goal. It's just, you can do this. Now, this is the one that is giving me concurrency. This one is allowing me in one hand to draw the screen 10 times per second. But in the other hand, I have the key listener running. I have this thread of execution that is listening to the keyboard and doing something with that. I am going to show you the method below. So action perform, call it by the timer, and this one, calling the repaint for the maze. That is the painting. My main, a new object from the class. The class is game. Size for my new object, because remember, game is inheriting from JFrame, so I can use set size to give size to the new window. And this one is the important one. That one put the window on the screen. In that moment, you notice the window in your computer. I need to close in some point the window, so I can use this instruction to allow the closing at the top of the window, well, Windows or Mac, to work. And in that point, my window is complete. The only thing that I need to do is now activate the timer. And this is the method that I have a bulb that create the object timer and start the timer. And it's the only thing happening in the main. Recommendation, always, 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 the main method should be small. The main method is like the boss of the company. The main method should have basically a lot of creating objects, sending messages to those objects, calling the methods. That's it. I am done. The main never, never, never is going to do validations or revisions or try, catch, whatever. Usually is very simple. Create the object or objects if your program have more than one window and put them to work. That's it. Finally, the key listener is running. The key listener is going to make you to implement these methods. We are only just going to use one, but you need to put all of them because it's an interface. You need to implement the methods, all the methods in the interface to accomplish the contract. And if you notice, this one is going to be called every single time that the user press a key. I can get from the event which was the key. This is straightforward from the Java tutorial. The only thing that I need is to figure out which was the key. Each key have a value. You can compare characters, but when you have the arrows, well, they do not have characters. They have some kind of key name. And as you can notice here, I have a pacman. So because I have a pacman, I can call the methods in the pacman. And in this case, the only thing that I need to do is to call those methods up, down, left, right. I am not doing the drawing. The only thing that I am doing is changing the values for the variables. Someone else is going to do the drawing. The timer calling the repaint of the maze redrawing everything in a new coordinates. This is the code that complete the game. And this is the diagram, a little bit fancier, that represent that source code. And yeah, this is a class diagram. Each of these boxes is a class. And what I have here is methods and variables. I use Asta. So in Asta, I have this X for the lines because I can click there and do fancy things. Don't worry about the X. It's because the tool that I am using. Yeah, it's the tool. So forget about the X. You are going to notice with the diagram that there are some things that we can improve. I am sure that after we take this and transform this to source code, hopefully you notice that, well, we can create a version 2. A version 2, yeah, you look into this diagram, even if you didn't check my source code, you can notice that I have these variables here, and these variables here. Can you make a suggestion about what should happen with those variables? Okay, those variables, they are in the childs, right? If they are in the childs, maybe you want to move them to the parent, because instead of having 3 different times the same set of variables, inheritance, you can move the variables to the parent, and therefore the childs are going to inherit. Now, if you move the variables to the parent, in that point, we do not have an interface anymore because now we want to have methods and variables. So you need to update this. And well, now instead of an interface that we start very fancy, very simple, well, maybe now we need something else. And that something else could be an after class or a class. yeah, these things here, and these things here, and things here, and here, and those are the names of the variable. Remember, when you have a relationship, the names of the variable do not appear here. You put here the variables that are attributes, but if those variables are part of a relationship, well, the line is the one showing the relationship. For instance, here in the class game, you do not have here maze, Pac-Man, and ghost, because, well, this is the ghost, this is the maze, and this is the Pac-Man. We are representing them with these lines. Obviously, this guy should be here. Again, is the tool that gives you access to move everything everywhere. This one should be here. This one is fine. This one is fine. Usually you delete those names because this is a problem with the tools. They go crazy. Anyway, you do not need the names. Not here, not in the lines. You go to the source code and it's obvious the type, and then you can review the names of the variables. Well, movement number one. Now, I have a question for you. In my game, I have the Pac-Man, I have the ghost, I have the power dot. If I ask you about changing the Pac-Man to a circle, do you know where to go? Because right now I put this rectangle. What do you need to do if I ask you to change the Pac-Man for a circle? The Pac-Man class, good. In particular, the draw method. In particular, what do you do? Draw rect for draw oval. I mean, you check for the API and you know. If I ask you to implement the different ghosts, because right now I give you the red one, the Doomy one. If I want to implement others and we want them to move different, what do we need to do? Can we create the ghost class as the parent for another 4? And could we have in those childs a different draw method with different ways to move? Okay, one more question. What if I ask you for a score? Because it's something that I would like to have, like the points. I am not worried right now about how to calculate the points. That is going to be another step. But right now, if I want to have the score, I mean, something on the screen showing me numbers, what do I need to do in the diagram? Because remember, we start with the diagram. It's like sharing ideas, right? What do we need to do? What could do for a score? Do we need another class? Could be a good idea to have a class score. Yes, that is correct. And you can do Blinky and the others. Yes. And the draw is going to change. They are going to move different. Yes. Did you notice that what I have in Maze was this item dot draw, and at least the Pac-Man is drawing yellow, the power dot is drawing in white, and this guy is red. So automatically, if I apply inheritance here and I change the draws for something different, that new draw is going to be applied, or do I need to change something in Maze? It's going to be automatic, right? Why? Because this array of items that I have here is polymorphic. Every single time that you call a draw from item in Maze, you are drawing a Pac-Man in yellow, you are drawing a power dot in white, you are drawing this guy in red. But if you add more kits here, you are going to call the draw method that corresponds to the particular element. And that is very powerful. I only need to add things here, and I don't care for things that I already did. Now, in particular, just to complete this, if I need score, what I do with my class score, which could be the best way to connect score with the rest of the program with the minimum number of connections. Do I put score where? Could you agree with me that we need a score inside of the maze in the same way that we put the ghost, the Pac-Man, and the power dot? I mean, the Pac-Man, the ghost, the power dot, and now the score. I mean, another element inside of the maze. So what about making a score another drawable element? Implement drawable, right? Now, I can have a score connected with game and therefore pass a score as a parameter to maze. Option number one. Or option number two, I can do with the score the same thing that I did with power dot, which basically means having a score connected with maze, which is already done because this connection here. A rule that we need to review: clear the diagram, clear the code. Lower number of connections, easy to read your source code. Now, obviously, unless there is a very good reason to put a connection, if I have two options, I am going to choose the option that allow me to keep the diagram clean. In this case, if I use this connection that is already done, if I make the new for score here, score and implement drawable, done. Is the only thing that I need to do in the diagram for the score. Really? Oh, let's check. If I do that, and I have a class score, and I implement this, yeah, I will need variables. I could assume that I need X and Y because I need a position for the score. I can put values there, or I can put the values here in the constructor, whatever, and they are not going to change. I mean, we're not going to have the score moving. An initial value for the score. Now, it's going to be only one value for the score always, and I need to update that one several times. I can use static or not, really just play with the options. In fact, the object is the one that could be static because we only need one score. Anyway, score. Initialize the position or not. We can remove this because it's always that position. Play with this. The only important thing is, because we do score, implement, draw, available, I need to provide this method. It's the only thing. And well, the color and a new instruction. Now I'm going to draw, but I want to draw a string, not a circle, not a rectangle, a string. And I am going to draw the value of the variable score. And well, if I am going to draw the value of the variable score, the only thing that this class needs to know or needs to give you is one way, a setter, to change the value of the variable. Again, it could be set score as usual, or you can put some semantic meaning here. And in the same way that we have up, down, left, right for the Pac-Man, we can have this increment score that basically is going to increment the score in this way. Again, here you can play with crazy algorithms that allow you to calculate the new score. and you can send as a parameter whatever you need to calculate the score, things that happen in the game. But the point is, there is a method that the only thing that it's going to do is change the value. And there is another method that the only thing that it's going to do is print the current value. Separation of concerns. If I do this, well, doing this and going back to the maze, and could you agree with me that you need to change this 3 for a 4? And could you agree with me that you need here item in the position 3 equal new score, and that's it? Well, I need to call the increment to the score in some place. Can I call here what happens if I call increment of the score there? Every time that the window is drawn, you get a point. So you're getting points just because you are alive. Again, you call the method maybe inside of a method collision or inside of a method eating, whatever. In this point, you can call other methods, and those methods can call in some point the increment. So the increment happens when you eat, and the eat happens when you if else calling methods make bigger this. But so far, if I call increment here, you get points because you are alive, period. Yep. Well, in the homework, you have this source code. If the code is empty, doesn't matter. The only thing that you need to do is to create a diagram, right? So the relationship. If the code is, if the method is empty or not, do not change the representation. So this is the maze. This is the diagram. This is the modification with the score. Now, what happened if I told you that I need the score with a different font or higher, biggest numbers? What do you think we need to do in order to change that? We need more classes? We need to do what? Well, we can review the API, right? And if we review the API, something that I want you to be aware is font is an object. Everything is an object. Pac-Man is the object, the maze is the object, the game is the object. Even the font that you use to draw the score is an object. Inside of my class score, I am going to use a font. I can define the name, obviously, the size, whatever. And there is a method to establish that font as the one that I want to use, and then draw the string. Obviously, my question is, okay, now you are using a class font that should be blue, like this one, all the classes that I am using from the library, right? There is a connection between score and font. And hopefully you agree with me, like, yes, score and font. Inside of the class score, I have something about the class font. Question for your exam. Which connection exists between score and font? Inheritance, aggregation, composition, association. Which is going to be the line? Dot, solid, triangle. Association, which means solid line. The arrow is pointing to a score, or the arrow is pointing to font, the arrowhead. If I didn't put font in the diagram originally, it's like I am okay with you using the default font. But when I go back to my diagram, I put this font connection, it's like, okay, there is going to be a personalized font in use here. So the programmer that implements score need to know how to connect font with the score, which means need to be aware of these instructions here. One last thing for you to think about it. Something that you have in the Pac-Man game is this score table, right? And the score table is there when you finish the game or when you start a new game. This is something that you store in some place, right? The best scores. So every time that I play the game, I know in the past, 1, 2, 3 days ago, whatever, the best score of someone, which means that somehow I need to give the game my name, my initials, and somehow this is going to be stored with my score in some place, and I need to have access to this. In the Pac-Man, usually I have this table. Question for you. Which are the requirements? And I am talking about the ovals in a use case diagram that I need to add in order to consider this. Do I need new classes in my diagram? Which ones? And how they are connected? How many? Moreover, the source code that I need for doing something like this. Can you think about it? And we review this idea next lecture. Any last question? Okay, guys, see you next lecture. Thank you.